So, welcome to my little session here. Hope you enjoyed this great event so far. Before we really start, please allow me to briefly introduce myself whenever this is working. Yeah. My name is Jörg Stryk. As you can see, I'm working with NAV for quite some time. I'm a Dynamics NAV MVP, and I have a 100% focus on everything in touch with NAV and SQL Server, especially performance optimization. And yeah, out of this huge area, performance optimization, troubleshooting, there can be plenty of issues, reasons for degraded performance. Today I want to pick out one special thingy all around blocking and deadlocking. This is something that occurs in any NAV system on a daily basis, when users have to wait for something, or if they get error messages and so on. That's just annoying, causing bad user experiences. So we face that every day. And what I would like to do in this session is, oops, that's too much, to explain a little bit to you. So what happens actually? What is locking? What is blocking? How does it work? Why do we have such a thingy? Why do we have to have such a thingy? So having a little glimpse behind the scenes, what's going on, explaining a little bit the mechanisms. Still, we will face more or less blocking issues, so that users have to wait. So for us, it's most important to find out what's going wrong. Yeah? Who is blocking whom? What is causing the trouble here? And I want to show you some quite simple, actually, thingies, methods, how you can easily, automatically keep track about blocks and deadlocks, so that you really could put the finger into the wound and see what's really going on, so that you are enabled to develop solutions. When it's about solving blocking issues, pretty soon we will end up in very individual specific cases. So there's no silver bullet where you can say, do this and then everything is fine. Anyway, there are still some classic issues, and I want to give you some inspiration just looking around in the standard code, what we already have, what we can do, and also having a little glimpse into NAV 2013, how blocking issues are avoided, resolved, what you can do even today. Again, my session is not using NAV 2013, so I stick to the things we have today. So everything you will see right now applies to NAV 4, 5, 6, and 7, and SQL 2005, 8, and 12. So I'm not such a science fiction guy, so I try to tell you something about what we have right now today. Everything you see in this presentation, at 12 o'clock you can download it from my blog. So you can see the slides, you can see the demo scripts and everything. Okay, and as I have been asked before, no, this time no innocent phone books will be tortured. So sorry about that. So, yeah, locking and blocking. These terms are used synonymously, which is actually wrong. And from a technical perspective, it's most important to understand that locking and blocking is two different things. Starting from the very scratch, the most essential task of any database server is to maintain, to administer data. So it has to insert data, it has to modify data, it has to retrieve data. That is the core business of any database server, of course also for SQL Server. And the primary rule when doing all this is to maintain the data integrity. Yeah? Thou shalt not screw up my records. This is the major rule for any database server. So that means that database server and SQL Server need to know at any given point in time who is doing what with the data, who is reading, who is writing. And to administer all this, the mechanism to do that is locking. A lock actually in itself is not a problem at all. A lock is sort of just a status information, or you can also consider it as a kind of flag added to a system resource, where SQL Server just flags this guy is reading, this guy is writing, or whatsoever. So when we look into these locking mechanisms we have, there's, for example, this one principle, optimistic concurrency. You maybe have heard before, that's something that almost every database is using. That means that no data is hard locked until it's modified. So latest in the moment your data is changed, hard locks will be established to maintain data integrity. It must not happen that two processes at the same point in time changing the same record, for example. That would screw up this record. So one is allowed to write, the other one has to wait, probably. In the native world, we had a quite basic locking mechanism. Actually, it was just optimistic concurrency, and then we had table locks on or off, no more nor less. The data management, or actually in charge of this data management of transaction handling, is actually this version principle we have, the versioning of data in the native box. With SQL Server, that's a totally different world. That's really two planets. In SQL Server, we have different lock modes. So we have shared locks, exclusive locks, update locks, and some additional status intent locks. I will look into this later on in more detail. So the lock modes define actually the kind of lock that is established. And then we have a lot of lock levels. It's also speaking about the resources that can be locked, the system resources. Also speaking of the lock granularity. So that means, yeah, here we see SQL Server is supporting row locking. Now that's what you can see here. But there are also other levels of locking. That's keys, pages, tables, and so on, up to the database. So this defines the resource, actually, so to speak, the place where the lock is established. And besides all this, it's most important to know that this is an escalating mechanism. SQL Server naturally will always try to lock resources on the smallest possible granularity, which is usually the row. Anyway, it is possible to start locking on a higher extent, but then SQL Server is able to replace locks of a small granularity by a lock of higher granularity. That means, for example, if we have thousands of row locks, these can be replaced by one single table lock. We will talk about this in detail. And besides all this, we have the so-called transaction isolation levels. This is, so to speak, the context within locks are established. And this also influences the kind of lock that is established and the resource level on which they are established. So all in all, as you can see, that's a way more sophisticated system, a way more complex system. But this is working for us, because this complexity means also a very high precision. Yeah? With SQL Server, we are able to lock resources with a scalpel and not with a sledgehammer we did in the Seaside server. And this precision is working for us. And generally, you can say that in SQL Server, we have way less blocking issues or conflicts than in a native box. Having a little closer look to these lock modes. Shared lock. A shared lock, for example, is just also called a read lock. If you read data, then the resource is flagged with a shared lock, and yeah, as the term says, it's shared. So other processes also could read the same record, the same data. No harm done, no problem. It's called a lock, but there's no conflict. Quite the opposite is the so-called exclusive locks. This is when a process or a resource turns Gollum, yeah, oh my precious, and tells the system, this is my record or whatsoever, and nobody else is touching it. This is exclusive lock. Also often called write locks, because latest in the moment data is changed, exclusive locks can be established. And then we have kind of hybrid status, that's the update locks. That is actually when data was read and now is going to be modified. So it's going to be updated, and these update locks will be established. And besides that, we have these intent locks. This is just additional flags to existing, especially to the exclusive locks, to establish a kind of lock hierarchy. So an example, in SQL Server we have these data pages of 8 kilobyte. And for example, if some record is inserted into such a page, this record gets an exclusive row lock. But as long as the transaction is open, SQL Server doesn't know, hey, what's going on with this page? Yeah, maybe there's more to insert, maybe more data to come. So SQL Server is able to flag the whole data page with an intent exclusive lock. Just telling other system resources, hey guys, take care, I'm writing to this page, maybe I have to expand my locks. And this, of course, influences if other processes are allowed to access this same page or not. So the locking in itself is not a problem at all. It's just flags where SQL Server manages data, administers its data. The problem arises if we get incompatible locks. So if multiple processes try to acquire locks which do not match. A pretty simple example. User 1 is opening customer card. It's reading customer Mr. Smith. There is no lock already, so he will ask for a shared lock. No lock is already engaged, so he will get this lock granted. He will get a shared lock. Now a second user wants to open the same customer card. Yeah, it's the same Mr. Smith record. He will also ask for a shared lock. So SQL Server will look up this matrix. Okay, you want to have a shared lock, and we already have a shared lock, but that's no trouble. What is that? Sorry. We already have a shared lock, but that's cool with me, so shared lock remains shared lock. No problem with this. Now, the first user wants to change something in this customer card. It's changing the address. Then he will ask for an update lock. Yeah, SQL Server will look up, okay, you want to have an update lock. We already have a shared lock. That's cool with me. You get the update lock granted. Go ahead, make your changes. Now, if the second user also wants to change something, maybe the posting group, because that's different departments, I don't know. He will also ask for an update lock. And then SQL Server will look up, sorry, we already have an update lock here. No, you have to wait. And then the second user is blocked. He has to wait, and this is the conflict we are struggling with. So if you have incompatible locks, I have to go back. So when we talk about these conflicts, finally we talk about probabilities. So how likely is it in this example that that indeed at the same point in time, really two users want to change Mr. Smith at the same time? The probability in reality is very, very small. So locking on a row level, on a record level, has a very small potential to raise any conflicts. The higher we climb in this escalation ladder, the higher is the probability to get conflicts. So imagine if one user has not locked just Mr. Smith record, but the whole table, and then we are screwed. That's maximum damage done, because that means that only one user is working with the whole customer table, and everything is closed down. So what we need to do is to make sure that we start and stay on the smallest granularity possible, because that has the smallest potential of encountering conflicts. And we can do this with NAV, a little bit, whenever this works. Today, since NAV 4 to SEC 6, we have a flag in the database properties always row lock. And this is a common misunderstanding that this is enabling and disabling row locking. This is bullshit. SQL Server, again, will always start at the smallest granularity possible, and this is usually the row. No, what happens if this flag is enabled? NAV sends a little hint to the SQL Server, which is called row lock. And that tells the SQL Server it must start on row level, it must start, and it must remain on row locking level. It's not allowed to escalate. So with this always row lock hint, we force SQL Server to start small and to stay small, having the smallest conflict potential. No more, no less. But of course, there is a reason. Why does SQL Server escalate anyway? So what's the point? Maintaining locks is costly. There are some costs, and the currency is memory, it's RAM. And maintaining lots of row locks is just consuming more RAM than maybe just maintaining one single table lock instead. And this is the reason why SQL Server will escalate. There are actually two ignition points for this escalation. The first one is the number of row locks that are already established. It's a built-in threshold. I don't recall the figure. It's, I think, roughly about 5,000 records. If you have 5,000 row locks, SQL Server will replace them by a table lock. That's one reason. With the row lock hint, we suppress this lock escalation based on the number of rows. So it's totally irrelevant if you lock 10 records, 5,000 records, 50,000 records, 5 million records. They will all be row locked. The second ignition point for escalation is memory pressure. If a certain amount of memory is just used to maintain locks, SQL Server will escalate anyway, regardless of this row locking hint. It will just raise the middle finger and say, no, I escalate, replacing, just to avoid getting out of memory. Because if you're out of memory, you are out of memory, and then that really sucks. So as it's memory consuming, we have to be careful with older systems and smaller systems. Always row lock does not work usually with 32-bit systems because of the memory limitations we have there. Also, you shouldn't use it with, or be careful if you have 64-bit systems with very small memory. So according to my experience, I can recommend it safely if you have 64-bit systems with more than 8 gigabytes RAM, that works cool. Unfortunately, or in my humble opinion, unfortunately, this flag disappeared in NAV 2013. For some reason, I keep secrets. So in NAV 2013, it is possible to naturally escalate for SQL Server. We have other advantages I will talk about later on. But if there's indeed the need to avoid this escalation in this system, NAV 2013 or whatever system, this could also be done on a global level by applying these trace flags. That's switches you can apply in the startup parameters, or you can start them up by code or something like this. And if this trace flag 1224 is applied, that also suppresses lock escalation based on rows throughout the whole system. There's another flag 1211. This is completely disabling the lock escalation. Also the escalation based on memory pressure. And that means if this is enabled, if you run out of memory, you run out of memory. So I personally am not really fond about these global switches because the problem is that they apply globally. Yeah, for a NAV system alone, if it's just the NAV database, that might be fair enough. But you might have other databases. You might have reporting systems. You might have BI databases, analysis services, or whatsoever. And what is good for NAV is not necessarily good for other applications. So just be aware of this, and this should be considered when working with these global flags. Just a second, sorry. The next thing we should look into is these transaction isolation levels. So the context within locks are established. And here it is important to know that today NAV is using read uncommitted isolation by default. That's also called dirty reads. Read uncommitted does exactly what the term means. It's possible to read uncommitted data. So for example, if you have a process, an open transaction, it's changing a value from A to B. That means that all other users who are doing this read uncommitted stuff are already enabled to read this new value B, even though this value is still in flight. It's not committed yet. Yeah, they can read it and they can process it for whatever reason. The trouble is if the process who was changing the value screws up, it's cancelled because of whatever weird reason, any error, I don't know, then SQL Server will roll back, and in the record still the original value A will be shown. So that means processes that have read dirty data have processed the value B, while the real value actually is A. So dirty reads can have severe impact on data integrity. Of course, the advantage is as long as you read dirty, you are allowed to read all and everything, so you never will face any conflicts, never you face any blocks here. And admittedly, most the queries you do in a daily in the vision business, just opening this card and reading that, they are run executed, read uncommitted. There's no harm done. Of course, we have processes where we must not have any dirty reads, where we really must make sure to only process clean data. We can do this by applying a lock table command. Lock table is not locking the table like in the native thingy. Actually, it's just increasing the transaction isolation level. So it's going up from the weakest end of the all isolations, so that's the weak end, up to the toughest end. That's the hardest isolation, serializable. Serializable makes sure that you read only clean data, but what comes with the package is that so-called range locks are established. So all the data that is queried gets locked. And unfortunately, SQL Server could create these range locks, means starting from the first candidate of the filter to the last one and closing down the whole range. And this really sucks, because if you have any overlapping result sets, if by sheer accident if there's any data in between, you cannot read this data because it's in this locked range. So this is a problem, but in a few minutes we will solve that. Have in mind that SQL Server naturally uses read-committed isolation. So because you've already started to work with SQL databases from outside NAV, creating your own queries, your own procedures, and so on. So if you do not specify any explicit isolation level, SQL Server will use read-committed. So SQL Server by nature just reads clean data. That could mean that it's more easily blocked than read uncommitted. Repeatable read, what this is, I keep secret for now. But I'll come back to this in a split second. So in NAV, actually, we end up between read uncommitted and serializable. That's the two isolation levels that are actually used. So it's dirty reads versus blocking, so pick your poison. Yeah? What do you prefer dying from? We influence this with lock table finds a true command, where we can explicitly apply locks in the code. In addition to this, we also have a little feature. There is a property in reports, and there's a method, transaction type and current transaction type, where we also can specify the isolation level we want to use for a certain thingy. But at the end of the day, we are still ending up with read uncommitted and serializable. So that's not really helping. No, this is the real deal. Since these NAV versions, we can apply a binary switch in the DB property tables. Yes, it's a field called diagnostics. By default, it's empty. There are some binary diagnostic switches that can be added to this. And if this one is applied, then NAV is using repeatable read isolation instead of serialization. So it's shifting down one gear. Repeatable read isolation still means to read clean data, but we don't have any range locks anymore. So if we had before overlapping result sets in a range lock, this always was locked. Now it's open. The range is open and we can work with this. This feature here will dramatically reduce blocking issues. Yeah, so that's really a difference between day and night. Let's see. Hello. All right. Sucks. Sorry. So in NAV 2013, sorry, repeatable read isolation is used by default. So, but again, this is possible today if you have these recent versions, and you find some Microsoft articles, documents, and stuff like this, where just claiming, go for it, go for it. And by the end of the day, I absolutely agree, go for it. But for let's say, political correctness, it's necessary that we have a little look into the small print. And this small print is called phantom reads, and I just want to show you what that actually is. So hang on a second. I'm doing this with a little SQL Server script. So making sure that I'm on the right database. Okay, so I'm now going to start a serialized transaction. Yeah, set transaction isolation level serializable, and then I just will run a query like Navision will do it. So just querying all sales lines of a certain item. So this is giving me 4 records, and the transaction is still open. So it's still in flight. I have applied an update lock. So I told the SQL Server, hey, I want to lock this really. So what actually happens is now SQL Server has closed down this range. So if I have a second process on the same database, which wants to insert some record here, adding something to this document here. No way. The range is closed down. That's serialized transactions. So I can stop this. I also will commit this. So this transaction is still open. So when I rerun the same query, so just executing this once again, sorry. There we go. So still 4 records. Okay, so now I'm changing the isolation level. Now using repeatable read. Doing, oops. So same query. Still the transaction is open in flight. Same story, try to insert something. What the hell? Did I forget to commit something? That's always. Sorry. Oh, bloody hell. So it always works in the test. Didn't I commit the other transaction? Ah, thanks a lot. I marked it, but I didn't execute. Yeah, that's true. Ah, that's when you get old. Ah, that's okay. So same thing again. Hopefully now I didn't forget anything. Bloody hell. Okay. I hope you believe me anyway. Actually, it is possible to insert if I do it the right way. And probably right after the session, I remember what I did wrong. Oh, that sucks. Okay, there was several other transactions open. Sorry. So, still. Okay, so one last try, and then I will skip this ashamed. Yeah, so this is what was supposed to happen. So there's no more range lock anymore, so I can insert something in this thingy here. So that means if in the same transaction that I still have open, if I rerun the same query, hooray, there's 5 records anymore. This is called phantom reads. Suddenly there is something there that hasn't been there before. This is the theoretical risk of repeatable read isolation. And this has been discussed quite some time in the community forums, also with Microsoft staff and then other Dynamics partners. By the end of the day, we can say that this is a problem that exists on the paper. So far, I never came across a phantom read problem with the NAV. I never heard about a phantom read problem. This also includes statements from some Microsoft persons. And even we tried to, I applied it in dozens of projects, even in lab scenarios. So phantom read is something that in real life obviously does not really exist. Yeah, and again, in NAV 2013, this is used by default. So this is obviously not really an issue. Anyway, the politically correct advice should be, if you apply this, test, of course. Yeah, what we also have upcoming is that the Navision database is used by external programs, that you just pump data to whatever external system, so firing queries from outside NAV. Again, by default, if you don't specify anything different, SQL Server will use read-committed isolation. And that means if a read-committed isolation is hitting an in-flight record, if it's open already, it will get blocked. So there is a chance to bypass this using read-committed snapshot isolation. Yeah? RCSI Antwerp. Sounds like a new TV show. No, it isn't. Read-committed snapshot isolation. It's a database flag or database property that could be used. And if that is the case, then what will happen is that whenever data is modified, SQL Server will maintain the previously committed version in the tempdb. So it will be a committed snapshot. So queries that coming from outside using recommitted isolation, they can read the committed record from the tempdb, which is a clean version, but an older version. That's pretty similar to the version principle we had in Seaside. But this is a database switch. So that means this applies to any change that happen in the Navision database. And So it is dramatically increasing the pressure on the TempDB. Using RCSI requires a 100% optimized TempDB. So it means dedicated physical drive, multiple files, and whatsoever. And then again, this maybe also should be discussed if you want to use that. You really want to use this, risking to have a permanent bottleneck on the TempDB, just maybe to support half a dozen of external queries. So I dare say that the most precise solution is to just specify the isolation levels and whatsoever directly in the queries that are coming from outside. That's maybe a little bit more work to do, but it's the cleaner solution. So anyway, this is the technical framework we can work with. Some stuff we can generally adjust. Still, we will encounter blocks. Actually, blocking is necessary to maintain data integrity. It's just the circumstances that make a block happen. So we will have these problems, and here it is most important to find out what's going wrong. This is the quest, the challenge. And I would like to show you just pretty simple things you could use to easily keep track about blocks so that you can see what happens, what's going on, who's blocking whom, what resources are involved, so that you can develop appropriate solutions. So, I already have installed this here. I won't do that during this presentation. You will get in this download package a bunch of scripts. You actually just need to execute in this sequence, and then they create the stuff you will see here. So what it does, I have an alert here. There is Windows Performance Monitor, you hopefully know, and there's a lot of performance indicators that are enabled, that are built into the system. So where we can get a lot of health information or condition information about the system. And one of these gazillion of indicators is the process is blocked. Yes, of course. SQL Server is managing the blocks, it's managing the logs, and knows exactly what's going on. So SQL Server, that's the one we should ask about the blocking. So here I'm monitoring this indicator process is blocked, and if it raises above 0, so if there's a block, then this alert will realize this. So this was just some test executions. Oh no, that was the stuff from before, yeah, true. So it will realize there's a block and could report it in the first step. But just counting the number of problems, that's not the big deal. An alert itself cannot execute code. So what this alert is doing, it's executing a job. Because a job is supposed to execute code. So I have a job here. And this one is just running a little stored procedure. And again, you get the source for all and everything. So you can also modify it according to your needs. So, and this procedure is just looking up who is involved, who is blocking whom, which resources are blocked, which log modes are used, what queries are blocked, and so on. And will this automatically write into a table? So what I do now, I have here my two ladies, Anna and Betty. And I just have some little mean code. So they're both going to try to lock the sales header. So Anna starts locking the sales header. And now if Betty wants to lock the same sales header, pity. Yeah, they hang. And now it's just a matter of a few seconds until this alert will execute. It has a delay of 10 seconds, so not executing any time. So it will fire up this job whenever the history is shown. Yeah. So every 10 seconds now we should get another execution. So it's all saved into a table, which I have called block. That's the table, and then you can investigate. So this is just a little SQL script to investigate these recordings. We'll just count how many blocks did I have, on which resource level. The duration is always, that's in milliseconds. What is the victims? What's the blocker, so to speak? What's the resources and combinations about? I can look into all the details provided by SQL Server, and then I can do whatever I have in mind. Counting the blocks per hours, the blocks per day. I can count the number of queries that are blocked, and so on. So I really get the full picture. And once it is stored in a table, you can query it with Excel and do your diagrams or whatsoever. So you just need it in a structured way to investigate. And for me, it's always important to count the problems, to really see what is a permanent problem, what's a persistent problem, what is something I have to solve quickly, or is it maybe just a single event which I simply can ignore or maybe postpone. So just removing all locks. Okay. So what we have now is a very complicated process. We have an alert, a job, and a table. Hooray. And that's all 100% just little SQL programming. So actually with just using the tools you already have. It's just a few lines of code. So, and it's an event-triggered thingy. It's automatically recording. So it's not necessary that if you have a block, jump into the system and solve it right now. You can relax. And then when you have some spare time, then you can check out what's really going on and make your mind about this. Yeah, this is a little bit, let's say, fuzzy when it's about deadlocks, the queen of blocks. Hooray. Deadlock is a very special circumstances, which basically happen like this. Two processes start easily reading something. Yeah, let's say number one is reading sales header, the other one is reading purchase header. No, nothing done. Now the first one starts to change the sales header, doing whatever. The second one starts to change the purchase header. Still, everything cool, no problem here. Now, if the first process also wants to lock the purchase header of the second user, no way. Yeah, we have a block, because it is already locked by this process number 2. This one is the one still continuing the work. But if this user now is also trying to lock the sales header from the first process, what we have then is a kind of crossover blocking situation. And this is what we call a deadlock. Every process is waiting for the other one to release the lock. They will wait until the end of days. They are dead. They cannot do anything. SQL Server has system processes that actively search for deadlocks every 5 seconds. So once a deadlock is detected, SQL Server will automatically resolve this. A deadlock cannot take longer than 5 seconds. Yeah, sometimes you have that if a user hangs and the system waits forever, 10 minutes, that's also some people call it deadlock. No, it's just a long block. A deadlock is a very short thing, but a very mean thing, because that means at least one user gets an error message. Because SQL Server will resolve this, it will pick the victim and roll it back. Yeah, those of you who were working with SQL Server 2000 back in the good old days, you remember that was a real error message for man. Yeah, you got deadlock was encountered, you have been chosen as a victim, your process has been killed. Boom. Today that's just this sissy message. Oh, sorry, there was a block. Do it again. Yeah. Once one process was rolled back, the other one could continue. There are some rules when SQL Server is picking the victim. It's basically 2 things we end up in NAV. That's the CPU time processes have spent so far, and the number of changes, the data changes a process has done so far. So SQL Server will always try to roll back the easiest process to roll back. So it tries to limit the damage. So you can never say it's always the second one losing this game, or it's always the youngest employee in the company. So it's really a matter of what they were doing. Yeah, so and as this is happening a little quicker than other blocks, we need a different thingy to investigate this. And basically, it's a good old pal profiler. So whenever, here it is. Yeah, that's even a standard template. And just remove things that we don't need right now. because there is a thingy that is called the deadlock graph. So just run it, and you will see something. So my ladies here, now we're going to try to force some deadlock. So this one is starting this way. This is, so Anna starts locking the sales header, Betty starts locking the purchase header. Here we go. So the locks are engaged. So now Anna tries to lock the purchase header, which is already locked by Betty. Locked. This, so far, we just have an ordinary block. Now, if it takes quite long, then our event triggers will start up and then record it. But now, if Betty tries to lock the sales header as well, so we can count 1, 2, yeah, so at maximum 5. So and obviously it was Betty losing this game, and Anna could continue. Just releasing all the locks. So what we have recorded now is these deadlock graphs. And at this point, I always wonder how much spare time they do have in Redmond. Why do they create pictures you can move around? So somebody must be really bored there. I don't know. No. Anyway, this information is something we can use. We have a chance to extract this. I just stop the tracing here. I can do this just by right-click and do an extraction of a single deadlock graph. If you have thousands of deadlocks or whatsoever, then there's, of course, there's a bulk export feature. So just extracting this graph to my desktop DL. So, and this little funny thing here is XML. Yeah, now we're talking. XML, this is something we can deal with. So we have all the information we need to know about the deadlock. Again, there's everything there, who is blocking whom, who is involved, which queries, which resources, whatsoever. And this XML we can feed to any application that is capable to deal with XML. So in the easiest case, and actually I consider Microsoft Excel as an onboard tool, we simply, when I get it here, just drag, drop to Excel as an XML table. And here we have it back in a clean structure. And you can do all the nice things you want to do, counting, doing your pivots, I don't know, whatever you have in mind. Same story as with the blocks. So to put some light into this issue, to find out what's going wrong. Of course, nobody wants to sit in front of the profiler and handle all this manually and watching and doing extraction and stuff like this. What you can do, everything you assemble in Profiler, you can also export into an SQL script. Yeah, there's some scripting features. And this is what I already have done here. So I exported the script, and using that code created from Profiler. Whenever it's, yeah. This is the script created by Profiler. Yeah, a profile is just a graphical interface to execute SQL code. So that's actually the same with the management student, all interfacing tools. Yeah, you just need to know that 148, event 148, that is the deadlock graph event. So, and this is just a little bit pimped. So where I specify an output file name, and there's some little file management attached to this job and so on. So this was started automatically when the service starts, creating a background profiler trace. That's this one here. And again, this has a little file management, so all I need to do is I start the job again. Okay. So what this little thingy is doing, it's closing the tracing, it's renaming it with a timestamp, and instantly starting a new trace. So and if everything was as it was supposed to be, that's okay, sorry. That's always a matter of security. Sorry. So here's the deadlock from just right now. Oops. Okay, so that means now we have an even more complex process. We have a trace and a file. Hooray. That's it. Again, that's 100% onboard features, just a little bit coding in SQL. No, nothing more. In the older days, there was the option still exists, but I do not recommend it today, just to be complete. There's also some trace flags you can set, and then SQL Server will write this deadlock information into the SQL Server error log. But this is a text file, and then grabbing out the information from a text file, that's hell on earth. Yeah, so XML, that's what we want to have. So I wouldn't go for this trace flags. Oopsie. So this is how we can easily keep track about blocking and deadlocking. So once we learn about what's going wrong, we have to open our minds to develop solutions, to fix that somehow. And yeah, actually this starts with a workflow. So this is the challenge actually the business consultants have to face. You have to really have a close look into the business of the process of the users, because we just have to be aware that just posting standard purchases versus standard invoices, that there can be any single point of failures, like GL entry or any warehouse stuff and so on, reservations and so on. This is something you should know, learning from your experience, knowing the application very well. So that is where it starts. If you know already this is potentially problematic, then maybe it's wise to even adjust the workflow a little bit. And then, of course, it depends how the business processes are implemented in the system, how it is encoded. So from a technical framework, we have several things we can do, using row locking to avoid escalation, using repeatable read isolation, being a little bit not too generous with lock table commands and so on, and lots of other stuff. Additionally, what is important today is to really think about how data is stored. Honestly, when we were working on the native database, developers cared shit about all this. Because it was simply working, or actually we didn't have any way to influence that. With SQL Server, it is most important to really think about how data is stored, how it is accessed, how long are transactions, when do I start locking, when do I commit, do I have any overlapping result sets? This is the challenge we have to face. So there is no silver bullet, and we pretty soon end up really focusing on very specific problems that only occur on a specific system. When it's about deadlocks, there are some other things to consider with a big question mark. The problem with the deadlock was that we had this crossover locking situation, which was annoying because one user gets an error message. If both processes, if both Anna and Betty would have started in the same sequence, so both starting with the sales header and then continuing with the purchase header, I just got maybe a block, but no deadlock anymore. So locking resources in the same sequence avoids deadlocks. But this is easier said than done. So once upon a time, there was a tool, the performance troubleshooting toolkit. There was a feature where you could assign locking order rules, and you could check the application code against these rules. You get a form with locking order rule violations and so on. And even if you just compare standard business process, just standard Cronus database, you get these locking order rule violations. Because it's not that easy to really accomplish this. Of course, it should be an approach, and in your custom development, I guess you have a bigger chance to implement this than modifying the standard or something. Another thingy is using semaphore locking. That's kind of traffic light switch telling other processes halt. That could be smooth, that there's just a traffic light and a process is reading the traffic light and just looping and waiting until the light switches from red to green. That's not really a technical block, but it's still just waiting, waiting without a block. And the other funny advice you get in some very older Microsoft documentation is you should lock a common master resource. That's a good one. How to do that? An extreme example. You start every business process throughout the whole system. You start everything with the same speech. GL setup, lock table, GL setup, find first, GL setup, modify. You cannot lock harder. And if you do that throughout the whole Navision system, I grant you, 100%, money back guarantee. You will never have a single deadlock. For the sales guys, that's very attractive. They can sell Navision with one single user license. You just need to make sure that you have a large office where you can queue the 150 users in front of that single PC. Yeah, because I hope you get my point. This is what happens if you do this locking common master resource. That's maximum serialization, zero parallelism. So that should not be the first shot you fire when you encounter deadlock. Yes, it resolves deadlocking issues, it avoids deadlocking issues, but this should be implemented in a very focused scenario, only where it's really necessary as kind of last line of defense. So, and have in mind, semaphore locking is something different than queuing data. Queuing data, that is maybe a smart solution, because queuing means you just press F11 to post something, and it's not the user process now waiting for the posting to be accomplished. No, why not just put it in some queue and let it post asynchronously with an application server? Asynchronous processing does not mean post once per night. Asynchronous processing could mean you just have a little delay of a few seconds or maybe a few minutes. This is the same idea we see in NAV 2013 using the job queues. Yeah, where a user just says fire and forget, and then it's put into the queue. The user can continue working, yeah, and then it's just queued, and then a separate process is taking care about the postings. Avoiding blocks for the user, giving good user experience to the human being that is doing something. Yeah, so this is just some general advices. Again, we will end up in very individual problems in real life scenarios. Anyway, I would to show you some, let's say, classic examples about blocking issues we have today in the current Navision versions. Just to give you some inspirations of what's going wrong and how you can solve it. All these examples I'm presenting now are provided under NG, which means no warranty, no guarantee, no support, and use at own risk. Yeah, so don't blame me if you screw something up. Yeah, starting with the document dimension thingy. This is a problem that will happen to anybody working with dimensions in the current systems. It's just a matter of how many dimensions you use and how many documents you have. Because this is the general structure of this table, document dimension. And here, especially the clustered index. The clustered index, that's the index that defines how the records are sorted in the table. And this is the standard sorting order. When you have a sales post, Navision will query the header and the line dimensions. So if this process A wants to post order number 100. Oopsie, that was too much. It wants to post order number 100. Without using row locking, without using repeatable read isolation, we will get a range lock starting from here down to there. And that means if user number B wants to post order number 200, pity, it will get blocked here. And this is a problem that sooner or later always occurs. It's a matter how many documents you have, because the core problem here is that the table starts first with the headers and then the lines. The more documents you have, the greater gets the distance from header to line. And the greater gets the range, the greater gets the damage. Yeah, even without repeatable read isolation or stuff like this, you can fix that pretty simple by just changing the clustered index. So sorting the data in a different way. Now using the document number as a primary criteria. Same query, same range lock, no problem. Yeah, just can up my mind how to sort the data, how to store the data, can avoid conflicts. I can show you later on how to change the clustered index if you haven't done that before, or maybe just do it right now. So I can check this out. So this is what we have, these key properties. And this is the standard layout. Of course, you never should change the order of a primary key. So key and index, that's different stories, but that's not the scope of this session. So what you can do is, for example, just change the SQL index property by copy-pasting the key content and then rearranging the columns into the appropriate order. It's flagged as clustered, and then when I save this, this change will apply. If you don't want to fiddle with the SQL index property, because that also has something, could have some issues, you can just create a new key. And flag that one as clustered. Have in mind, changing clustered indexes can be a huge workload. You change the table definitions with all the consequences. So this is definitely something to be done after business hours. Okay, so a small thing which could have huge impact. So, you probably have heard that before. In NAV 2013, the whole dimension fuss was completely changed, upside down. Now we don't have these copying all these gazillion of records. I guess you're pretty aware of this. Maybe just briefly, today in the new version we will have just a table with all the possible combinations or the used combinations of dimension values. And this number, that I think it's an integer number, which identifies such a combination, now is used wherever it's necessary. So the records are not copied that time and so on. So this is a problem. This is gone in NAV 2013 anyway. Another thingy you probably came across during this event already, this famous line in code unit 8090. This is something you find anywhere, so even the older versions. Yeah, what it does. So as you can see here, that happens pretty early in a posting routine. So why do we lock GL entry when doing a sales post? This only happens on SQL Server, and there's a lot of, let's say, lock announcements with the lock table statements which don't do anything. GL entry is the only exception where instantly there was a find command issued, so the lock was indeed engaged. Well, the idea is, so to speak, if you look into a posting routine, it starts usually with a document posting, then the customer posting, then the item posting, and the GL posting is quite at the end of this whole routine. So with this code, actually we make sure in the very beginning of a posting routine that we have a grip on the end. And this increases our chances to survive that thingy. Yeah, so certain deadlock issues can be avoided with this. Anyway, today we have also some Navision business processes which do not create a GL entry. If you just move around goods, if you just have a shipment without any invoicing, there never will be any entry in the GL entry. So what's the point of locking GL entry, risking blocking issues, if it's totally not necessary? And this could be changed that way. So I changed that little code here a little bit. So what I did, I added a new flag, post to GL, yes or no. And then I just start a little bit more thinking. Yeah, I check the inventory setup for expected cost posting. If you use expected cost posting, then also a shipment will create a GL entry. So if I don't use expected cost, if it's an order, I only want to ship and no invoice, I can be sure there is nothing to post to GL. And so I bypass this lock. The same could happen on the purchase side in code unit 90. It's just not the ship, it's the receive flag I have to check. And this is feasible to use wherever you have business process where you just move around goods and maybe you have the invoicing at the end of the week or at the end of the month or whatsoever. Usually in the purchase department you have that. And this could dramatically reduce the amount of blocking conflicts on the GL entry. And again, not this, but actually it's the same way of thinking, is established in NAV 2013. Yeah, you heard about it in the keynote. Where also there's just a little bit more thinking. That now you have also a setup where you can actually tell the system you want to have the classic way, or you want to use the new way, the more intelligent way. avoiding this locking later on when you really create a GL entry. But again, this could be done even today. Another one. When we have documents or whatever tables, often we have subsequent records in related tables or something. Like here in this example, purchase header, you also find it in sales header and some warehouse stuff. In the onDelete trigger, so when you delete a record, that the code looks up all related records in a subsequent table to delete them as well, just to clean up. Warehouse request is a classic one because unfortunately, or so should I say fortunately, warehouse request table is only used if you use the whole warehouse management, if you use all the logistics. You might have customers that don't do that simply. So just, hello. The funny thing is, with this kind of code, the standard code, where you just fire a delete all command, that means that SQL Server instantly starts to flag, to engage some logs on a higher meta level, on an object level. And this alone could mean that this is causing blocks for other processes. And the funny thing is, these higher logs are even engaged, even though if the table is completely empty. So if you have customers that don't use this warehouse management at all, there will never be a single record in the warehouse request table. Still, you will face blocks on an empty table. That's outrageous, insane. And the solution is so simple. Just, again, a little bit more thinking. Maybe just check if there is something to delete. If it's not empty, then delete. And this is avoiding locks, so avoiding blocks. You will find this in NAV 2009 already. In many areas, this is already out of the box changed, but not throughout the whole system. So whenever you come across such a thingy, it's doing no harm, because if there is anything to delete, well, then we have the blocks and the locks whatsoever. The same applies actually if you have modify all or something. Yeah, that also would be polite to ask first if there's something to modify and then do it. Yeah, very, very little thing which could have a huge impact. And getting even better. Reservation entry. Yeah. Now we could have maybe a little vote. Who does not think reservation entry sucks? No one. Okay. Okay. Yeah, that's a pain. The eternal quest or the eternal conflict we have in reservation entry is this. The records are sorted by entry numbers. Just as they appear, they will be inserted into the table. But the reservation management is used in actually two ways, which are quite different. We have one way using the reservation entries on a document level. So where just from one warehouse document or whatsoever, a bunch of reservations are locked. And the other way to work with reservation entry is item related. So just looking up reservations of one certain item. And this naturally causes conflicts overlapping result sets. So this is why we have always issues on the reservation entry. In the older Navision versions, on some customizations I've seen that, you can make Navision to not use the reservation at all. Today it's hardly possible to really skip this. But if you have a chance to really bypass it, if it's just causing trouble and you don't need it from a business perspective. Anyway, you will also get blocks on an empty reservation table. And the reason is this function here. There's a function called lock, which is called from, I don't know, dozens of places throughout the code. Just hard locking here. Yeah, and to solve this, do it the cowboy style. Yeah, if it's empty, skip that, exit. Yeah, but also it doesn't do any harm, because if there is something, then I process the standard code. Just making sure that I don't do anything stupid because I'm trying to lock an empty table. Yeah, and the best one for the last. Again, reservation also has been changed in NAV 2013. I think now one of the major changes is that the entry number is now created by auto-increment. And I'm pretty sure that there are lots of other changes in the whole reservation management, yeah, because that's a tricky thing since it was introduced. Anyway, the last one is number series line. You also will frequently come across. What you will experience, or maybe have already experienced, is something like if you have huge batch postings, so where you're creating thousands of invoices or whatsoever, that during that time nobody is able to create even a new item or something. Yeah, that you get a block on the number series line. You ask, what the hell? Yeah, invoices, I want to create an item. What? Why? The problem here is, and I guess the female audience will agree, size matters. Yeah, and this table is too small. Because, spoiling all the fun. So, go away. So the problem is, what could happen is, number series line is used in that way. A record is looked up, usually to posting routines or posted purchases, for example, to retrieve the last number used and to increase it by 1. This, of course, must be locked, this record, to maintain data integrity, else we will get primary key violations and whatever. So, of course, locking is a must here. But it could happen that while this modification happens, that an intent-exclusive lock is established on the data page. Now, since this table is very small, that means that all or most of the records can be stored on the same data page. So by just locking this single record, it might happen that neighboring records are locked as well. In a, let's say, normal online business, when users are interacting, this is not very visible, this problem, because it's F3, enter, you get a new number, and that's committed instantly. But you will experience this if you have long-term batch routines doing massive postings or so on, where the number series line table is permanently stressed. So to solve this, we can do that. I'm adding a few fields here, dummy fields. And I have a code unit that is now creating these dummies. And now it looks like that. So what I have done here, I have 8 dummies, each 250 characters filled up. So it's 2,000 characters per line. And I inserted now 5 lines. So that's 10,000 bytes, more than 10,000 bytes. The size of a data page in SQL Server is 8 kilobytes. So what I have done here is I inserted one data page, at least one data page, as a spacer in between the real records. And this makes sure that every single record is stored on its own dedicated page. I don't care about page locks anymore. Yeah, so with this, it looks funny, but it really helps. So believe. With this, I dare to do this because number series line has only a very constant set of records. Yeah, there's just a few dozens in it, and maybe it's once per year when you fill with the number series, you add some lines, and then you can add the dummies as well, and so on. I never would dare to do this in kind of item ledger entry or something. Yeah, that would be hilariously stupid. Yeah, item ledger entry is used in a completely different way. Records are added to the end. There is nothing happening in between. And of course, doing this on item ledger entry or something that would make the hardware suppliers rich, yeah, selling their storage systems. Now, again, classic one, and with a small effort, can help a lot. You get also these demo objects in this download thingy. Yeah. Think a little bit. Yeah, I hope now you have an idea. So just to roll this up now. So again, the most important thing is locking is something different like blocking. Even though we use the terms synonymously, it's the blocking we have to deal with. That's the trouble. Locking in itself is not a problem at all. This is something which must happen. Locking must happen, and also at a certain degree, blocking must happen simply to maintain data integrity. So it is impossible to the approach to have an NAV system which is 100% without any blocks. Yeah, it's just a matter of circumstances, how users work and so on. You have 100% control if it's a system which is only used by machines. But since we have human beings interacting with the system, they can always do something stupid, which will cause conflicts. So we have some things we can do from the technical framework to improve the situation, to avoid a lot of row locking, repeatable read isolation, and so on. And we have, let's say, quite simple mechanisms to find out if there are conflicts, what is going wrong, so that you get ideas or inspirations how to solve these problems. As you have seen, if you have blocking problems, sometimes it's very small changes that have huge impact. It's not necessarily to completely disembowel a code unit and turn it upside down or whatsoever. Sometimes it's really just small things. But the challenge now is to the developers and the business consultants. They have to have a higher awareness. You really have to think through your business process, what they are doing. It's not just as in the old days, if you click that button, this form opens, hooray. No, now today you really have to know what data is displayed, how is the data queried, how is it stored, do we have overlappings, do I read it clean, do I read dirty or whatsoever. But the sooner you face these challenges, the sooner you will be able to create an optimized system where you only have the amount of blocks that are really necessary. So really having the minimum blocking, so giving good user experience, happy user. Yeah, that's what we want to have by the end of the day. Yeah. So let's check. This is the very first presentation. I'm in time. Yeah. So that means you should have plenty of time for questions, if there are. And yeah.
You showed a script about logging deadlocks. What is the impact of the system? Do you recommend that we just set that up for a new NAV installation and just have it running to ensure you got the historic information?
So the question was, what is the impact if you run this deadlock tracing script or block detection maybe in general, if it has heavy impact? No. The way I show you here is event triggered. And it's, for example, the deadlocks, the blocks is a passive way of recording. So only if it happens and there's a delay of 10 seconds. So it does not stress the system much more. The downside is that there's a little, let's say, fuzziness there. We have a kind of blind window of 10 seconds, which is fair enough for Navision. This could be changed into an active mode to have a higher frequency of looking for blocks, but that will cause pressure on the system. So the way you have seen it here, the event-triggered way, it doesn't do any harm. The same is for the deadlock tracing, even though if you have a massive amount of deadlocks, because in the trace file, I have specified a maximum file size of 500 megabytes. So if you reach that limit, it automatically will stop. So really to make sure that there's moderate impact, or actually not really an impact to the system. Now, of course, it depends if you have gazillion of blocks and deadlocks, but then I guess the tracing is your smallest problem of all. So, no. So the short answer is no, it doesn't do any harm. So, any more? Yes.
A while ago, I got a complaint from a user that during a certain posting process, a certain table was locked. But when investigating using code coverage, the table was not used at all in that process. Now I'm wondering, is there any way to investigate how a certain table might be locked without it being accessed by the code? Okay,
so the question was, if I got it right, that there was some blocks experience, but yeah, but when checking with code coverage, this table wasn't even shown there. Okay, just guessing without seeing the problem. But what happens also is that we have blocks, not necessarily on a table, but on a related structure like this sum index, the vSIFT. That could be, and this is not visible from the Navision code because the code has no idea about vSIFT. It's happening in the background. Also, what could happen is, you heard about this loopy code, and what's singing the same song is, if you have flow fields that are filtering on another flow field. So if you have a three-level structure, this is impossible for NAV. Navision cannot look down from level 1 down to 3. And what will happen is that the vision will automatically resolve these flow field filters, retrieve the full results and loop through it. Yeah, so that could be a reason that you suddenly get some query executed on SQL level, which are not obvious in NAV. If this really applies to that problem, I can't tell. So that's, maybe it's just a bug in the code coverage. I don't know. So.
I didn't look at the flow field, so that might be a cause.
Yeah. So okay. Oh, yeah. Well, that's a good question. Basically, it's the users suffering from this block you have to ask. Yeah. So the question is about the quality of block. How do you decide if it's a problem worth fixing or maybe to ignore? Is it the question?
Well, we've in the past seen blocking problems that turned out to be the fact that the SQL server was totally misconfigured, so that it's actually not a problem in the application that you fix, but it's a problem. It's a hardware configuration problem that's actually the root cause, not the
Okay.
software itself. Which performance indicator did you use to look at to decide if you need to look in NAV or if you need to look elsewhere?
I don't think I understood this question right, because hardware issues cannot lead into blocking.
It's performance.
Yeah.
If your SQL server is really fast, then you're less likely to get blocking.
Yeah. Okay. That way. Okay. Yeah. No. But actually, if you have seen, so you encountered a problem because there was a hardware misconfiguration, so everything took longer than it was supposed to take. So you had long blocking times and more conflicts. Nonetheless, I would, of course, the first priority for me would be to fix the platform. We need to have a stable platform which should carry the whole system. And then, it depends on where exactly this problem occurred. Maybe it is then automatically vanishing once you have fixed the hardware. But if it's still there, and if it's just giving bad user experience, then definitely I would try to solve this somehow. So this is really difficult to get some quality of a problem. Because you might have blocks on application servers that you cannot ask them. They don't have any user experience, but still it sucks. So, and this is why I count, so that you really can see, okay, I have that many hundreds, thousands or whatever blocks per hour per day on GL entry. Then you can say, okay, give this bypass a shot. Yeah, that's a quick thing, maybe where you can achieve a lot. So, but that's what I mean. That is always a very individual case. We cannot give any general answer. Sorry. Yeah. Any more questions? Yes, please.
Is there a difference between the NAS and the normal user in terms of locking rules? And is there a way to give the privilege to the normal user against the NAS?
So the question is if there's a difference between a NAS and a client user, and if there's a chance to assign priorities in the blocking. The answer to both questions is actually no. So a NAS is just a faceless client. It's communicating with the SQL server exactly in the same way. So it could face technically the same problems. Unfortunately, or how to put it, yes, there is a feature in SQL Server where we can influence the deadlock priorities. I have no idea how to do this with locking, but there is a switch called deadlock priority where you can tell a process to survive a deadlock or to be more or less the victim of a deadlock. But this is a flag that needs to be assigned when the process is established, so to speak, and Navision cannot do that. So with Navision, we cannot use this set deadlock priority command because you cannot inject it somehow from outside. It's something the process itself has to ask the SQL server. That's maybe something to address to Microsoft for future versions, to have something like this. And then it would be possible to say if there's a conflict, if there's a deadlock, it's always the NAS that should survive. Because if an automated process breaks down, it often has the problem to resume the processing. And for a user, maybe it's just easy to say okay to the error message and restart. So today we cannot do that, but what maybe is handy, have in mind there's a CAL command called lock timeout true false. We have in the database properties, we can use this lock timeout. That means if there's a block after the amount of seconds, by default it's 10 seconds. If a block takes longer than 10 seconds, SQL Server will automatically cancel the transaction and roll it back. My experience is that users prefer to have that, because that means they press something, start some processing, and in a decent time they get a feedback. Even though it is a negative feedback, but they know, hey, the system is doing something. Okay, I'll retry or do something else. Yeah, it really sucks if you don't get any feedback. So if you don't use the lock timeout, then the user has to wait forever, and Navision just hangs. There's no message. You don't see what's going on. So for most users, this really sucks. So if 10 seconds is okay, or if the timeout should be longer, that's, again, an individual thing. But then again, the application servers or job schedulers and so on, they maybe have a problem with the timeout. So just have in mind that you can disable the timeout with a CAL command, lock timeout, true, false. So in a code unit, you could place a line like this, lock timeout, in the brackets, GUI allowed. So if it's an online user, you use the lock timeout. If it's a NAS, you don't. Yeah, so this is maybe, but then again, from a technical point on SQL Server, it's picking its victim automatically. Okay. Oh, yeah. Select latest version. I have to admit that I have not the faintest idea how that really works with SQL Server. If there's a new call issued, Jesper Falkebo is here. Maybe he can answer this. Do we have a mic? Oh, maybe you just have to shout.
Okay, so the question was. So the question was, how does select latest version work? And basically, it just bypasses our internal data caching. So it forces a new call to SQL Server to read the latest data.
Oh, that's a cool thing. Any more questions? Now we have a microphone. If you prefer to speak the mic, if you just hand it over there. So, thanks.
Hello. You said in NAV 13 there are changes in the reservation management. Do you think it will impact on the lot tracking too?
This is a question you should ask me in a year from now, when we have the first real-life scenarios. Yeah, so I ran, of course, some benchmark tests in my lab, but on a Kronos database. So in the Kronos, I didn't see these blocking issues yet, but this is not realistic. So this is something we can hardly predict. Of course, the idea is that it helps, but what will be the impact in real-life scenarios? This I cannot tell. So we all hope for the best. Okay. Yeah. Any more? Yeah.
It is very difficult finding the place in the code which causes a deadlock by looking at the deadlock graph in the SQL profiler. Do you have any tips for this?
To find the vision context of this blocking and
to
deadlock.
find the place in the CL code.
This is really tricky. So today you cannot do that. So what you need to know is you have to have a very good knowledge about the application, and you need to know how Navision is translating the CAL code into SQL code. And I hope you all know very well about Waldo's blog. Yeah, Waldo Eric Wouters, he's all around here. Several years ago, he wrote some articles showing how CAL statements are translated into SQL statements. And with this, if you know that, and that's not rocket science, you can see from the statements where you get them from, and knowing the user who is doing this. If you know Navision, then you can have a pretty good guess where this is coming from. If you have pointed out, let's say, a rough direction where the problem is coming from, then it's the client monitor you should use, because the client monitor, you can start on the Navision side, and then you can also trace down the Navision code. No more we have today, but with Navision 2013, maybe you have seen it in the slides, the new debugger has a feature that's called SQL trace. that means that if this is enabled, Navision sends a separate statement to the SQL server, which is telling the user ID, the Navision context, and a little bit of the code stack that was executed. The reason is we don't have the user delegation anymore. So today we can really identify it's Anna versus Betty and so on. We don't see that in 2013 anymore, no user delegation. So blocks and deadlocks, we will always see just NST is blocking NST. Yeah, thank you. But that was the reason why now we have these additional commands for the profiling. For the blocking, it's a tricky thing. So that's pretty new and not fully, let's say, tested. I haven't tested fully. So far, I could not make the system to reveal this information also when I have a block or a deadlock. But that's maybe just the next logical step. And with this, that's really a cool thing. You directly see the object ID in Navision and can really point the finger. That's where the problem is coming from. So that's a start, and we have to see what's really coming up and how this will be used in the future.